This is an introductory lecture for Geography 125. It will introduce you to not only the many physical systems that are indigenous to our natural and cultural world, but it will also provide you with a variety of working definitions for the course. There are several important concepts that I would like you to take away from this initial lecture. The first of which is going to relate to what a physical geographer does in relation to the concept of scientific discovery and knowledge. Another important area of understanding will be how science actually functions, how we take observations and our understanding of the world around us and develop a deeper scientific system of knowledge to explain it. Next, we'll take a look at how we establish standards within physical geographic research with the concept of a benchmark and how even benchmarks will begin to change over time as landscapes continue to evolve. Next, we will be taking a look at the history of the discipline, how it moved from being merely a capes and bays pursuit to one that looks more closely and more scientifically with the application of things like mathematics and mathematical modeling at how landscapes develop and change over time. Then we will take a step back and really attempt to understand where this interest in physical geography began for us. We will move into the prehistory of our culture, of what it means to be human, and see if we can find similar interests or similar concerns regarding spatial concepts and landscapes. One of the first areas that is important to understand with regard to the topics that we'll be covering in the course is how interrelated the many natural systems of the planet are. Physical geographers attempt to understand the connections that exist between natural and cultural features, both in modern and historic and even prehistoric landscapes. The image that you see to the right of your screen typifies the interconnectedness that exists between the natural and cultural world. These unique statues represent this connection between the natural and cultural world. They're part of the landscape that we assign to the historic city of Ayutthaya in modern Thailand, Southeast Asia. The statues represent a later period in this prehistoric city that was initially established in the 14th century AD. The geology of the lower Chao Phraya River basin provides us with the material means for the carving of these statues. It was also advantageous for the development of this prehistoric capital city in Southeast Asia. The carvings, along with much of the architecture for this now abandoned city, was produced from basement bedrock that was associated with the tertiary and quaternary geological age for this region. Much of this rock material was sedimentary in nature. Upon closely examining this photograph, you can see the red sandstone associated with much of the building architecture, while these very ornate later statues that were carved when the Buddhists took the city in the 18th century. These are produced from contemporaneous sedimentary rock, in this case limestone, very similar to the kind that is common to the bedrock of Wisconsin and places like Tennessee and Kentucky. So in this religious and political capital now abandoned, we see the connection between human economies and societies that develop in these watershed environments. They become, in a sense, part of a developing civilization, and we see them also reflecting, in a sense, the history of landscapes within the region. This interaction between natural and cultural landscapes will be a major theme throughout the course. Another major theme that we can see at work here, and we'll look more closely at when we are studying the geology of the planet, is the interaction between material and energy in our earthly system and ultimately in our solar system. So what is physical geography? Let's consider that a little more closely. Physical geography is a natural science. It's an environmental science that emphasizes, in this case, the Earth's geophysical systems. A big part of understanding how these geophysical systems work is to understand the chemistry behind this. There is a specialty within physical geography known as, uh, in this case, geochemistry. Geochemists look at the interaction between material and energy. And so one of the other themes that you will be exposed to throughout the remainder of the course is that when you look at a landscape, you're really looking at a constant interaction between material and energy. It's something that makes all earthly landscapes dynamic in nature. They are always existing within a state of change. But we are a part of this puzzle as well. Many geographers today and geologists recognize a new geological epoch. We'll be discussing epochs more thoroughly later in the course. However, the new epoch that we are technically a part of makes humanity the centerpiece of it. In this case, it is referred to as the Anthropocene. So, what places us at the center of this new chapter in geological time? Well, really, the last 2 centuries of our contributions chemically to the planet. We have contributed to the chemistry and biochemistry of the ecosphere, the biosphere, along with all living fauna and flora. We have contributed to the atmosphere. You will be reading extensively about a phenomenon known as the greenhouse effect. And in this course, as well as the entire discipline of physical geography, we look at these kinds of phenomenon through a scientific lens. We interact with what is now considered to be the process of scientific research. And there's really 6 parts to this. We observe phenomenon. Once we do that, we develop hypotheses to explain what we see. We don't stop there. We continue by designing experiments, sometimes in the world around us, sometimes within controlled settings such as the classroom or lab, to test these hypotheses. Following this, we attempt to predict the outcome of these experiments, things again designed to test our explanations. We then attempt to predict the outcome of additional experimentation as we constantly go back to the drawing board to test and retest our initial assumptions about a phenomenon that we're observing and measuring. We conduct experiments and observe what actually happens as part of this process. And then finally, we attempt to draw conclusions. We attempt to formulate theoretical frames of reference, which then would be used to develop rules with regard to how the natural environment behaves. So as physical geographers or as students of physical geography, we ultimately are interested in how researchers formulate questions, how they test these kinds of questions, and then ultimately how they contribute to a body of knowledge that explains for us the natural world. Now let's take a look at a working definition for what we have discussed thus far, a definition for physical geography. It's provided for us by Robert Christofferson, a professor emeritus of geography and geology at the American River College, taught there for over 30 years. He states that in this case, physical geography is a science. It studies the relationships among natural systems, geographical areas, society, cultural activities, and then it ultimately accomplishes what we have been building thus far in terms of our understanding of what a physical geographer does and what physical geography is. It looks at the interdependency of all of these constructs or concepts over physical space. This definition really embodies what I believe you will come to understand regarding physical geography and its place in the curriculum not only of what we offer at Wisconsin Lutheran College, but your own studies, whether you are pursuing a major area of study in education or history or a science such as biology or chemistry. The key takeaways from this particular definition is that it is a scientific pursuit, that it looks at natural and cultural systems, and that it examines these concepts, these systematic concepts, over geographical space. And then I would interject one additional concept, which is that it also looks at these across time. Well, in order to more deeply understand the definition we just looked at, let's start out by attempting to understand what science really is, how it behaves, how we ultimately achieve a scientific system of knowledge or a body of knowledge. As we look at how science behaves through the lens, in this case, of Thomas Kuhn and his work, The Structure of Scientific Revolutions, I think it will help us to better understand why recent editions of texts, such as the kind that we use for the course that we are engaged in right now, why they are important. Kuhn, as is the case with other scholars writing on how Western science has developed over time, takes a look at how we get to the level of a class text or a course textbook. He recognizes the course textbook to exist philosophically at the end of a very long, drawn-out historical process of discovery and of scientific testing. In his discussion, Kuhn provides us with the idea of how new discoveries contribute to the revolutionary practice that is science, and how these discoveries eventually become facts. Kuhn, as he begins to describe how the history of discovery has led to the development of modern science, describes and discusses Hermann Fisu's discovery that light moves faster in air than it does in water. He describes how this principle, this concept, which was observed, measured, explained, and tested and retested by Fisu, was something that ultimately has helped us to understand more about what a photon is and how it behaves in the natural world. These discoveries ultimately contribute to what become paradigms. In this course, we recognize a paradigm to be a scientific model. It is an agreed upon pattern-driven explanation of a given environmental event or phenomenon. Over time, as new discoveries are made, paradigms will change. They'll be reformatted in a sense, providing us with a better, well agreed upon explanation of the world around us. But what we must always remember is that a discovery and its contributions to scientific models, ways of explaining or knowing the world around us, are not static in nature. Like human knowledge and scientific tradition, we realize that any and all explanations of the world around us must be things that can be reproduced. They must be things that are also observed and measured again and again. And they are things that are tested and retested. And it's through this process, this very arduous process of science, that we are able to then raise ourselves to a level where we can have agreed upon facts for the world around us and for things we observe in that world. Let's take a moment to look at this slide. If you are an art major or you are a student of history interested in the overall impact of the French Revolution on European society, you may already recognize not only the painting, but you could probably associate it with the artist. This is the Death of Socrates, portrayed by the Napoleonic court artist Jacques-Louis David. As you know, Socrates was a 5th century Greek philosopher. He was the instructor for Plato. And Plato becomes an important name and individual in the growth and development of science and of a scientific process. But the painting does not exist in isolation. It is a product of the time at which Jacques David lived and worked. It is also a product of Plato's description of Socrates' final days. It, like scientific explanation, the hypotheses we develop, the paradigms that we ultimately construct, are all representations of reality. Modern science, in a sense, continues to paint and repaint landscapes that it studies, or phenomenon that it observes, that it measures, that it explains. And though we strive to understand those realities as facts, we realize that they too will change as we continue to improve what we know of what we observe. Plato is important in this process because Plato, again a pupil of Socrates, tells us in his allegory of the cave from his Republic that much of what we know is a mere representation, a shadow on a wall of what truth really is. He also challenges us by looking at our explanations of reality as mere shadows of reality to also realize that how we understand reality will change and will continue to change as we get closer and closer to the truth. So, scientific discovery, scientific fact fall prey to the same kinds of potential flaws that we run into when we attempt to understand something from outside of it. And as our ability to more deeply understand natural and cultural phenomena improve, our explanations will also improve. But like any paradigm, we will continue to seek improvement over time. Well, so what are we left with? We're left with the idea that textbooks really provide us with what is currently understood regarding an observed, measured, and tested phenomenon. Textbooks record new traditions in science, but they also represent a history of precursory thought. So the textbook that you use for this course provides you, the reader, with not only what is currently understood regarding research in the area of physical geography, but it also provides you with a history of thought that has contributed to what we know today. It will, in a sense, introduce you to the discoveries and the hypotheses that were tested in order to develop theories. Theories, in this case, are smaller units within scientific paradigms. They act to shape or give us a frame of reference for what we see in the world or what is being explained to us. That explanation is then built upon through testing and retesting, through the development of new hypotheses and with new discoveries. So let's look here for a moment at what we would give as a working definition of what a theory is. A theory is a system of explanation for an observed reality. It is also something that, when taken into consideration with other theories, will structure larger paradigms or schools of thought regarding a particular aspect of the world around us or what is being observed in that world. So given all of that kind of pie in the sky kind of explanation of what we understand to be the scientific method, let's take a closer look once again at what physical geography is and how potentially things have changed. We'll use an example in this case. In 1999, a new measurement of a famous commonly studied location had occurred. Mountaineers Peter Athens and Bill Krause used their GPS system to determine the elevation of the highest benchmark in the world. In this case, they were assessing the current elevation of the highest point on the mountain range that is known as Mount Everest. A benchmark is a very important cartographical concept. It's a surveyor's mark that is used as a reference point when measuring altitudes. It gives you a sense of how many feet or meters you are above or below mean sea level. What they came to realize was that this very important benchmark, the highest point on the face of the planet above mean sea level, had in fact changed in elevation. And I do have to mention at this point that there is an error in this slide, and I'll point that out as I explain what has changed. In this case, we were given a new elevation for the summit, 8,850 meters, or 29,028 feet, and that's the error. You can see it's not 12,035 feet, 29,028 feet above mean sea level. Now in 1954, the official measurement was 8,848 meters, or 29,035 feet above mean sea level. Why am I giving you all this information? Well, in fact, what researchers came to realize is that the Himalayan plateau, which this amazing phenomenon is a part of, was in fact increasing in elevation over time. Benchmarks, our standards, also change. What this means is that we have a mountain range that is being, through tectonic force, pushed further and further up away from the center of the planet, in this case 3 to 6 millimeters per year, and that this all-important benchmark that is associated both with the Indian and Asian land masses is in fact changing. What this means for us and for our understanding of scientific knowledge and how it grows and develops over time is that we must recognize that change exists within the natural world. We must also recognize that the technologies that we use to understand these seemingly foundational concepts that are dynamic, that are in a constant state of change, that our technologies also continue to develop in such a way as to allow us to more accurately measure things or measure them in a different manner. This means that the science of the physical geographer and of the geologist must not be static, that it must understand that the landscapes that it studies are in a constant process of change, and that our understanding of those seemingly solid landscapes will also change over time. Well, given all of this, and given what you are looking at in the opening chapters of your course text regarding the scientific process, let's take a step back and look at the history of what is today geography. As is the case with the landscapes that physical geographers study and classify and categorize, the discipline itself has experienced a process of change. In this case, it has experienced changes in its interests, in its practitioners, and in how it identifies and explains phenomena in the world around it. One very important point of change in the history of geography is that it is no longer a capes and bays pursuit. What I mean by this is that it is not the memorization of physical locations and land features. Those are things that you will experience as part of this lecture series and as part of this coursework, but it is not the only or centralized concept in how we understand the physical world. This change in perspective, getting away from merely memorizing locations and land features, is something that we associate in this case with the work of Eratosthenes. When we look at the writings of this 3rd century scholar, we realize not only that we have an individual who initially coins the term geography, he was an Alexandrian librarian, but also we have an individual who begins to more deeply understand and attempt to explain the shape and size of the planet that we all live on. His experiences and ideas, his hypotheses and how he tested those hypotheses will become an important understanding for us as we begin to delve into how we today recognize and even map the world around us. But this concept, and this is an important point here, this concept was nothing new by the 3rd century. It was nothing that was inherently localized to the Mediterranean either. These were concerns, ideas, concepts, which we can trace back archaeologically to the start of the human story. So then, given this more holistic perspective regarding what a physical geographer actually studies, let me give you a much more formal and user-friendly definition for this discipline. Physical geography, as you can see, is the study of the Earth's physical systems, systems of global climate, geological features, terrestrial materials, natural energies, and organic life. And like I mentioned earlier, these systems, how to truly understand them at a very deep level, we really have to look at them through the eyes of a chemist or an anthropologist or a biologist or a physicist. So as an anthropologist, let me end this initial introductory lecture by giving you some ideas regarding how we can reframe this area of study. As I said earlier, our interest in really understanding landscapes and where they are located physically or spatially and how they have changed is nothing new. In human prehistory, again, that period of human history in which we do not have written records or that time prior to the historical record or the historical era, we do have an interest in environmental issues, in the natural world, and in preserving or maintaining the resources of that natural world. Cave paintings, such as those at the French site of Lascaux, are indirect evidence for what even psychologists understand to be cognitive mapping of the local landscape, the world around us, and how we explain it. Throughout the archaeological record, we see members of early non-agricultural or foraging societies wishing to understand the whole earth, its inhabitants, and the physical elements or natural processes of change which help in survival. Early 19th century Plains Indians, for example, utilized charcoal staining on hides to generate local maps. Wichitans, the Arikara, and other language groups produced hides that expressed and recorded celestial bodies and their movements throughout the seasons. They depicted trade routes and even mythological journeys in the afterlife. In fact, many of these depictions are not unlike the kind of GPS or GIS resources that we produce even today. Here is an example of early biogeography. Here we have a engraved antler from the French site of Ambry-Blanchon. It dates to 32,000 years ago and represents a kind of celestial calendar. Archaeologists don't really understand how these particular markings were utilized. However, their patterned nature connects them to many of the celestial movements associated with seasons, even to this day in central and southern France. Other similar engravings have been recovered, some contemporaneous to what we see here, others at a more recent date, demonstrating drawings of animals and insects that were known to exist in a seasonal pattern, others maps. But whatever the case, we see in this archaeological example an interest in being able to not only understand when a natural phenomenon was to occur, but to be able to predict it. And again, this is a very important concept within what we recognize today to be modern science. Here's another example, an antler carving recovered very near to the previous example. It dates to a time period in archaeological circles referred to as the Upper Paleolithic. The specific date, or even finite date range for this artifact is not known. However, it does match styles of artifacts which would have coincided to a date range of between 40,000 to 10,000 years ago. Anthropologists, archaeologists looking at artifacts like this recognize it to be some sort of resource procurement strategy record. When and how particular kinds of animals or even plants would have been gathered or foraged and then utilized in community survival. Again, another good example of prehistoric biogeography. It also gives us a working example that physical geography is nothing new to the story of humanity. So let me end by giving you a general overview of physical geography and what we would like to accomplish in this particular course. It is a summary that will also give you an idea of how and why we have the course schedule that we do. When you look at the latter pages of your course syllabus, you will see a topical layout of material that we will slowly work our way through. This topical layout will also guide your weekly readings. First and foremost, you will see that physical geographers will, by their nature, attempt to understand the physical nature of the planet. They will incorporate the celestial objects that are associated with our galaxy, and they will attempt to understand how the Earth relates to those objects. The Sun-Earth relationship, for example, is one of the most important of these initial understandings. From there, we will begin to look at the Earth's physical nature, its physical and chemical makeup. The Earth's atmosphere will be studied, and it will demonstrate to us that the Sun-Earth relationship is very, very important. We will take a look at things, processes such as the absorption of light or heat energy from our sun. From there, we will begin to look at the nature and origin of landforms and how they change over time and how they relate to other earthly systems such as the atmosphere. We will address the Earth's biogeography. In other words, those things, those living organisms which currently inhabit or survive within the Earth's biosphere. And then we will frame all of this in relation to the concept of human culture. Another way of looking at it is we will attempt to understand landscapes and the physical nature of the planet in relation to the concept of human ecology. This is where the idea of memorizing landscapes, the locations of river systems, the elevation of mountain ranges, and their relationship to the edge of tectonic plates or continental shelves. That's where these particular understandings begin to amass, and these would be things that you would memorize and be tested on. What drives all of this, and that, in a sense, this course is a part of, is the idea of human culture. This course and all of the information that you will be gathering, poring over, memorizing, and understanding is all part of our human adaptive success story. It is part of a much larger gathering of rules of behavior which we learn and transmit to one another, one generation after the next, as we adapt to the world around us and ultimately maintain our survival. So I hope you enjoy this course. In the weeks to come, we will be covering a lot of information, and you will also be exposed to a lot of information through your course text. At this point, I will be ending our first lecture. However, I have a reminder for you, which is to make sure to always review your notes, review this material if you have time, and then make sure to keep up with your readings. Take care and see you next time.